So I'm going to show you how to do matrix 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 multiplication um, by using an example. So let's say my family went out to the apple orchard and they picked some apples and pumpkins and corn. And so Sarah went out and picked 6 apples, 2 pumpkins, 8 pieces of corn. Benji had 3 apples, 1 pumpkin, 2 pieces of corn. Phoebe, who loves apples, picked 8, 1 pumpkin, and 0 corn. All right. Um, And then we can also say that apples cost 25 cents each, pumpkins were $1.50, and the corn was 50 cents. Must have been quite expensive. So here, if I were to make this into a matrix, I could say that's 6, 2, 8, 3, 1, 2, and 8, 1, 0. And this is a 3 by 3 matrix. And we'll call this A. We'll call this matrix B. And you can see that it's 0.25, 1.5, and 0.5. And this is a 3 by 1 matrix. If I want to multiply matrices, I have to make sure that if I multiplied A times B, I would get a 3 by 3 times a 3 by 1, and that's fine because the columns from A match the number of rows, and so when we finish, we should have a 3 by 1, which means that matrices are not, multiplication with matrices is not commutative, because a 3 by 1 times a 3 by 3 can't work. But more importantly, I mean, that is important, but more importantly is, take a look at what happens when I multiply this. I'm going to say that I have 6, 2, 8, 3, 1, 2, 8, 1, 0 times 0.25, 1.5, and 0.5. And it works like this. You take the 6 and you multiply it with the 0.25. Plus, you take the 2 and you multiply it with the 1.5. And then I take the 8 and I multiply it with the 0.5. And so I did my row with the column. And I'm going to do that again. I'm going to say 3 times 0.25 plus 1 times 1.5 plus 2 times 0.5. And then my last row is going to be 8 times a quarter, 8 times 0.25, plus 1 times 1.5, plus 0 times 0.5. Oops, oh, I kind of messed that up. 0 times 0.5, which gives me my new value. Let's say 6 times, well, that was smart. That's going to be $1.50 plus $3 is $4.50 plus, oh goodness me. Let's see. So that's going to be $1.50. That's going to be $3. And 8 times, that's $4 to 7. So Sarah spent $8.50. Benji spent, let's see, that's 75 cents. That's $1.50. And that's $1. So 250 is 325. And then lastly, I have 8 times, that's what, $2, $1.50, that's 350. So if you take a look, what this actually means is Sarah ended up spending $8.50. Benji spent $3.25 for all of his items, and Phoebe spent $3.50 for her items. And that's why matrix multiplication is useful, because you can have huge groups of data, and then you can have the value of this data, that information, and you can multiply them together. And the key is, remember, you're multiplying the rows by the column, and then you add them all up. I'm going to show you real quick how to do this on the graphing calculator. If I can in fact find the graphing calculator. Let's see. Oh, it's already up. So real quick, you turn it on and you have to press you have to press second in matrix, and I'm going to edit my A. Now my A I'm going to say is a 3 by 3 matrix. And I'm going to enter my data 6, 2, 8, 3, 1, 2, 8, 1, 0. I have to actually get out of this and then go back in and then go over to edit again. And I'm going to go down and I'm going to edit B and make it a, what do we say? We said it was a 3 by 1. And so my values were 0.25, 1.5, and 0.5. And once again, I had to get out of here and then back in. So now I want to do A times B. So I'm going to say A times B. And when I do that, you can see you get the same thing. 8.5, 3.25, and 3.5. And that's it. So I hope this was useful. I really do love matrices, and they are quite neat. So I'm going to do another video on reduced row echelon form, and that'll probably be it for the evening. Thanks.